Welcome everybody to the fourth example of our power series discussion. So here in this case, we want to use the power series of a known function 1 over 1 minus x to get the power series of a new function 5x over x squared plus 1. And so we can do that really by just doing a substitution and multiplying by another polynomial. So remember that for our power series expansion of 1 over 1 minus x, that one is going to look like our interval, our sum from 0 up to infinity of just x to the n. And we had a radius of convergence on that one of the absolute value of x less than 1. So now if I want to, can I do a substitution to transform this function, our 5x over x squared plus 1, into our function 1 over 1 minus x? Well, for 5x of 1 plus x squared, what we can do is, let's just start with 1 over 1 plus x squared. I can really write that as 1 minus a negative x squared. And so I look at this as the composition where I'm really taking a negative x squared and I'm putting it into x. Well, I can do that substitution, and what I end up with is my sum from 0 up to infinity of now minus x squared raised to the n power. And so kind of simplifying that a little bit, I have the sum n equals 0 up to infinity. I have a minus 1 to the n power and an x squared raised to the n power, which, raising a power to a power, I have a value of minus 1 to the n, x to the 2n power. And so this gives me something that's kind of in the direction of what I'm looking for 1 over 1 plus x squared. So now I'm just missing this 5x. So let's see how we can put that in there. Okay, so we've got our expansion of 1 over 1 plus x squared looking like minus 1 to the n times x to the 2n. So we need a 5x in there, and so really we just imagine that I'm going to multiply by 5x on both sides. And so what happens in that case, n equals 0 up to infinity, minus 1 to the n, x to the 2n, I can bring that into the inside. And so I end up with a power series expansion. So sum from n equals 0 up to infinity. I've got a minus 1 to the n times 5. And then I've got another x times x to the 2n. Well, I can combine those to give me something that looks like a minus 1 to the n times 5 and x to the 2n plus 1. And so if I was writing out the terms of this power series, what would they look like? Well, when n was 0, when n is 1, when n is 2, we plug those in, and so we get an expansion that looks something like 5x minus 5x cubed plus 5x to the 5th minus 5x to the 7th plus, and so on and so on and so on. And so we've got this infinite polynomial that really is the embodiment of our function 5x over 1 plus x squared. And where is this going to work? Well, now kind of coming back to our interval of convergence, what did we have for our original power series up here? This was going to be where our x squared, because that was our substitution, was going to be less than 1. But if we kind of take the square root of both sides, what that ends up being is just where the absolute value of x is less than 1. And so what happens in that case, we have an interval of convergence for our absolute value of x less than 1. And so if we just took a value for x, kind of plugged it into this function, we could figure out what this series was actually going to look like, and kind of answers one of our questions of what does a series sum to? If we can find a power series expansion of a function, plug in the right value, we can figure out what the sum of the series is actually going to be. But we have to find it in the interval of convergence, so that's going to be the criteria, can we find it in the interval of convergence for which that function does have a valid representation. So I hope you've enjoyed this, and I will see you guys next time.